Water. It is a relatively simple compound, but one that is vital to all life on our water planet. We play in it, wash in it, and drink it. It seems so plentiful that we often take it for granted. And yet, as the world's human population grows, our supply of this necessary substance dwindles. Already 1/4 of the world's 6 billion people live without an adequate supply of fresh water. Even though South Florida is blessed with an abundant supply of fresh water, many people don't realize that most of that water depends upon a vast network of wetlands, known as the Everglades. And fewer people realize that this resource is threatened. More than 100 years ago, the Everglades was a vibrant and complex ecosystem of water, aquatic life, plant life, and wildlife that covered almost 9 million acres. Over the past century, an increase in human population and development has altered this precious ecosystem and reduced it to less than half that size. Only now are we realizing that without the Everglades to supply our water needs, the current lifestyle of South Florida's 6.2 million residents would not be possible.
Hi, I'm Philippe Cousteau, inviting you to join me as we journey through the Everglades, following the waters that flow slowly south through rivers, swamps, lakes, and marshes to the vast saltwater lagoon known as Florida Bay. Along the way, we will explore the natural wonders of this unique ecosystem, learn how humans have changed the balance of nature, and investigate efforts now underway to restore the Everglades to its natural condition. Most people think of the Everglades as the national park that lies to the southwest of Miami. In fact, the Everglades ecosystem has 3 vital parts: the Kissimmee River, Lake Okeechobee, and Everglades. Sometimes referred to as the KOE ecosystem, this vast watershed begins near Orlando and runs south all the way to Florida Bay. Our journey begins at the system's headwaters, Reedy Creek. Just a few miles from the theme parks of Orlando, my team and I have discovered a primeval world, one governed by water and as yet unspoiled by man. Each year, during the wet season, summer rains flood these woodlands, filling seasonally stagnant waterways such as this one with an influx of pure, fresh water. As levels rise, the overflow moves south through a network of shallow lakes and marshlands into the first part of the Everglades, a meandering, branching channel the Indians named Kissimmee, the River of the Long Water.
From the lakes of Central Florida, Philippe Cousteau and his expedition team have followed the flowing waters south to a branch of the Kissimmee River. The team's destination is the River Woods Environmental Laboratory, just north of the town of Okeechobee. Here they will be joined by a group of students from Forest Hill Environmental Academy and scientists from both the South Florida Water Management District and the River Woods Environmental Laboratory. Together they will explore the past, present, and future of the Kissimmee River and investigate its influence on the rest of the Everglades system. At River Woods, Philippe Cousteau and his team are briefed by Lou Toth, chief scientist for the Kissimmee River Restoration Project. Historically, the Kissimmee was a meandering, shallow river that snaked its way through broad wetlands on its 103-mile course to Lake Okeechobee, a distance of only 50 miles as the crow flies. Like the rest of the Everglades system, the Kissimmee River was at the mercy of the seasons. During the dry season, the river would become a shallow stream. But when the rains came, it would overflow its banks and flood up to 40,000 acres of wetlands, providing a rich habitat for a diverse mosaic of flora and fauna. In response to a series of disastrous floods in the 1940s, there was great public outcry to tame the Kissimmee and stop the flooding of farms and homes. After years of deliberation and planning, the U.S. Army Corps of Engineers took on the monumental task of channeling the Kissimmee River. In just under 10 years, from 1962 to 1971, 30,000 acres of floodplain wetlands were drained, and the once winding river was transformed into a straight, uniform canal 56 miles long, 30 feet deep, and 300 feet wide. Named the C-38 Canal, this man-made waterway provided the flood control farmers and homeowners demanded. A number of scientific studies determined that the health of the entire Everglades system was in jeopardy as a result of the channeling project. Fisheries were devastated and bird populations plummeted. Migratory waterfowl decreased by 92% and the bald eagle population by 74%. The once majestic Kissimmee, so vital to the health of the Everglades system, was seemingly gone forever. In 1992, federal and state agencies created a restoration plan to revive the Kissimmee River. Experts concluded that the best way to restore the natural habitat would be to fill in all or part of the flood control canal and restore water flow to the original river channel. By the turn of the century, the plan had become a reality. For a first-hand look at the restoration effort, Philippe Cousteau takes to the air with Lou Toth.
Scars of the old river are still visible next to the banks of the canal, like a fading memory that remind us of what this river once looked like and provide a blueprint for future redress. Ahead, we can see the point where the waters of the canal are diverted back into the historic channel. As water flows once more through these stagnant waterways, it brings new life. In a few short years, this section of river will complete the transformation to its natural state and once again harbor a diverse population of birds, fish, and river animals.
During the years following the creation of the canal, the ecology movement was born, and nature was no longer considered an enemy to defeat. By 2010, the restoration program will fill 22 miles of the canal, over 1/3 of its entire length, and demolish 2 of the 6 dam-like water control structures. The project will restore 43 miles of meandering river and more than 25,000 acres of former wetland, effectively revitalizing this once vibrant mecca of life. This restored ecosystem will provide habitats for more than 320 species of fish and wildlife, such as the crested caracara, the national bird of Mexico, the endangered bald eagle, and many more. Back at Riverwoods, Philippe and the team join a group of foster children who have found refuge at the real-life Children's Ranch in Okeechobee. Together, they will travel along the river to assist in its restoration by planting 1,000 cypress trees in a filled-in section of the old canal.
In a way, the Kissimmee River Project is a penance for past wrongs. Perhaps we are finally realizing that we share this planet with other living creatures, and that our survival is intimately tied to our environment. As we arrive at the planting site, I feel pride at being part of the sacred act we are about to commit. These young children, who have known such adversity in their lives, will now work to undo the damage caused by those who came before them, and in so doing, send a poignant message to those who would challenge the sanctity of our natural world.
At the end of the day, planting completed, the team heads towards the next part of their journey. The second leg of their journey takes Philippe and his team to Lake Okeechobee, the liquid heart of the KOE system. Historically, this shallow lake provided important habitats for wading birds, migratory waterfowl, and countless species of fish and game. It served as a natural reservoir during the dry season, renewing itself when summer rains swelled the Kissimmee. During the summer wet season, lake levels rose, overflowing the southern shore and sending a 40-mile wide, 100-mile long blanket of water southward over the Everglades.
This phenomenon, known as sheet flow, inspired Marjorie Stoneman Douglas to name the Everglades the River of Grass. It is the sustenance of the Everglades, the annual ebb and flow of water that define the life of the glades. Human endeavors have interrupted this natural rhythm of wet and dry seasons. Now, the Everglades often receive too much water when they don't need it, and too little when they do.
As the first Europeans settled on the banks of Lake Okeechobee, they began a process that would eventually change the face of the lake. No longer did shorebirds waddle through the shallows, or frogs, fish, and alligators plumb the depths of the lake like before. Instead, wetlands were drained to create valuable farmlands. And to protect these farms from flooding, an 85-mile-long dike was built around the lake in the 1920s. In the years since, additional flood control and water management projects have left their mark, forever changing the course of water through Lake Okeechobee. Instead of moving into the Everglades, water now passes through canals into an area known as the Everglades Agricultural Area, or EAA. Over the past century, generations of farmers and elected officials have drained large parts of the wetlands to open them for agriculture and urban development. Today, the EAA measures 750,000 acres in size and is the largest single agricultural area in the United States. In addition to irregular water flow, pollution threatens the future of the Everglades. Water, rich in nutrients such as phosphorus and nitrogen, drains from the EAA into the traditionally nutrient-poor Everglades with disastrous effects. But there is hope for these troubled waters. As part of the Lake Okeechobee Protection Program passed in 2000, scientists are working to restore more natural water flow through the lake. And rather than place restrictions on agriculture, they are finding ways to treat the water and remove excess nutrient pollution. At the heart of this treatment program are huge areas of former farmland, which have been enclosed behind levees to act as natural buffers along the border between the EAA and the Everglades. Water is manipulated through man-made wetlands in these areas, known as stormwater treatment areas, or STAs. Naturally occurring plants are then used to remove phosphorus from the water in a natural way and cleanse it before it leaves the EAA and moves into the Everglades. The team travels to one of these stormwater treatment areas to meet with South Florida Water Management District scientists. With a helicopter scouting ahead, they travel by airboat to conduct water quality and invertebrate population tests. With a suitable location chosen, Philippe and scientist Robert Schuford collect samples from an invertebrate testing site.
Invertebrates are animals which lack a backbone. They often require an aquatic habitat and are found in every part of the Everglades system. Invertebrates such as snails, water bugs, and alligator fleas provide a vital food source for fish, wading birds, and reptiles. They also provide important information regarding the health of the environment. In response to water quality changes, entire invertebrate communities may shift location or change in size, giving scientists valuable information about chemical and biological alterations in the environment.
After samples are collected, the team joins scientist George Paluga to conduct water quality testing.
Water quality tests are conducted regularly to assess the effectiveness of the STAs. A liter of water is divided into different vials for analysis back at the lab. Tests are conducted to determine the water's pH balance, as well as levels of phosphorus, dissolved oxygen, nitrogen, and several other substances. Phosphorus levels as low as several parts per billion can have drastic effects on the health of aquatic ecosystems. The goal is to reduce disastrously high phosphorus levels from their current 200 parts per billion to a safer 10 parts per billion. If successful, nutrient removal, along with the restoration of more natural water levels throughout the wet and dry season, will have a tremendously positive effect upon the health of the ailing Everglades and is a step in the right direction.
Testing completed, The team transfers to the helicopter to travel to a pumping station with the call sign G310. One of the largest of its kind anywhere in the world, this station is powered by decommissioned military submarine engines and can pump up to 1.25 million gallons per minute. It is the last step in the journey of water as it flows out of the STAs and into the Everglades. From Lake Okeechobee, the team moves south across the EAA and into the Everglades, following the shallow wall of moving water as it flows 150 miles south through seemingly endless expanses of sawgrass sloughs on its way to the Gulf of Mexico and Florida Bay. In addition to being one of the nation's great wilderness areas, the Everglades is the main source of water for South Florida's 6.2 million residents and 30 million annual visitors. Below the swamps of the Everglades, the geological foundation of South Florida is made of porous limestone. Known as the Biscayne Aquifer, this huge rock layer soaks up and stores water like a gigantic sponge. Almost 90% of our fresh water comes from this one aquifer, which runs all the way from Boynton Beach to the tip of Florida. Without the Everglades to replenish this aquifer, South Florida would soon run out of water. Traveling by helicopter, the team flies over what is left of the real glades, dubbed Everglades by early settlers because they seem to extend forever. The team passes over cypress swamps and sloughs into vast areas of sawgrass, punctuated by tree islands. Tree islands are mounds of thick peat, or high remnants of the underlying limestone rock that are shaped like teardrops due to the constant flow of water. In the 1940s, there were more than 1,000 tree islands. Today, there are only half that many.
From the air, it is easy to see the fingerprints of man. Water control canals crisscross the landscape, harnessing and diverting the great sheets of water. Barriers like Tamiami Trail act like dams against the sheet flow, and urban sprawl continues the press of civilization.
The team arrives at Shark River Station. To get a better idea of the overall flow of water in the surrounding landscape, Philippe Cousteau takes to an airboat.
Traveling by airboat, I am in awe of this river of grass. As we glide over the sawgrass, so named for their sharp, saw-like blades, I am reminded of the words of the late Marjorie Stoneman Douglas. There are no other Everglades in the world. They always have been, one of the unique regions of the earth, remote, never wholly known. Perhaps with dedication and hard work, they will stay that way.
Reunited with the team, Philippe Cousteau follows park ranger Bob DeGrosse through the sawgrass towards a tree island. Near a small cluster of white apple snail eggs, Bob pauses to explain the plight of this endangered species. Somehow, apple snails can predict natural water levels from year to year. In response, they lay their eggs at a certain height on the sawgrass, high enough to stay dry, yet low enough for the hatchlings to reach water before they dry out. Unnatural water levels render this tiny invertebrate's water meter useless. Consequently, either the eggs are drowned or the hatchlings dry out. Low populations of apple snails have led to the endangerment of another unique species whose primary diet is this tiny snail, the snail kite. Other animals are endangered too, like the Florida panther, which used to roam the Everglades in the thousands, but which now number little more than 50. Their dwindling numbers are in response to a shrinking and debilitated habitat. The plight of these creatures and others underscores the urgent need for a more balanced attitude towards this remarkable ecosystem. Continuing on to a tree island, they make an exciting but dangerous find, an alligator nest. Every year, female alligators build a small mound in which they lay their eggs and are very protective of their nests. The 6-foot female makes her presence known to the team. Knowing that an alligator is able to outrun a horse for short distances, Philippe keeps careful watch on the nearby female as he inspects her nest. Several yards away, the team finds an alligator hole. Alligator holes are natural depressions in the limestone several feet deep, kept from filling with mud by the constant thrashing of an occupying alligator. These holes provide a watery oasis during the dry season for all types of animals. They are one of the most important features of the Everglades. Back in the air, the team follows the course of Shark River as it winds towards the Gulf of Mexico. As the fresh water flowing south mixes with salt water from the Gulf of Mexico and Florida Bay, the familiar fields of sawgrass and tree islands slowly give way to mangrove swamps. For a closer look at this mixing zone, Philippe Cousteau meets with researchers from the South Florida Water Management District at the Key Largo Ranger Station. Together, they will travel by boat to Taylor Slough and head upriver, battling thick hordes of mosquitoes and navigating densely packed mangrove swamps to explore this wild and unforgiving landscape.
Closely monitoring this aquatic environment, researchers are exploring the way human alterations of fresh water flowing out of the Everglades has increased the salinity of the bay. Also of concern is the input of nutrient-rich water from the Everglades. Nitrogen or phosphorus in the water can cause an effect known as eutrophication, or over-fertilization. Eutrophication can cause lethal algal blooms, which block the sunlight that fragile saltwater ecosystems such as seagrass beds and coral reefs need to survive.
Emerging from the narrow river channel, the team leaves the Florida mainland behind and heads towards the open bay and the coral reefs beyond. On the way, they pause to don mask and snorkel to explore these shallow areas. Seagrass beds are vital ecosystems which protect against erosion and provide rich habitats for a myriad of animals, including fish and many types of invertebrates. Development and pollution threaten grass beds along much of Florida's coast. The next and final stop for the team is a coral reef where they will don scuba gear and dive into these rainforests of the sea. Though coral reefs cover less than 1% of the ocean's surface, they represent some of the planet's most biodiverse and valuable habitats. Reefs serve as vital nurseries for the world's major fisheries and are also primary sources of food and income for coastal populations around the world. Today, coral reefs are threatened. Already, some 25% of the world's coral reefs are gone. In the Florida Keys, development, declining water quality, and changes in water flow have caused the reefs to suffer a fate similar to that of the Everglades. There is hope, however. In the year 2000, Congress approved the Comprehensive Everglades Restoration Plan to restore water flow through the Everglades and re-establish a more natural cycle of wet and dry seasons. The plan will cost almost $8 billion, and if successful, will ensure that the Everglades and South Florida will have a future to be proud of.
As we begin this new millennium, we are faced with an uncertain future. Shall we continue to abuse our water planet, and in so doing threaten our own future? Or do current restoration efforts symbolize a new beginning? Marjorie Stoneman Douglas said it best. How far they will go with the great plan for the whole Everglades will depend entirely on the cooperation of the people of the Everglades and their willingness at last to do something intelligent for themselves. There is a balance in man, one which is set against his greed and his inertia and his foolishness. Courage, his will, his ability slowly and painfully to learn and to work together. Perhaps, even in this last hour, in a new relation of usefulness and beauty, the vast, magnificent, subtle and unique region of the Everglades may not be utterly lost.